do this problem. Given as a string of open and closing, your task is to remove the minimum number of parentheses so that the resulting string is valid and return any valid string. Okay. Formally, a parenthesis string is valid if and only if it is the empty string contains only lowercase characters. What? If it is the empty string contains only lowercase characters, or right, it's kind of hot. Let me turn the fan. Of course. Bro, what the fuck? Okay. It can be written as AB, A concatenated with B, where A and B are valid strings, or it can be written as A. So this is not valid because why? There's 1, 2. Oh, there's like an. Okay. It is the empty string contains only lowercase characters, or it can be written as AB. A concatenated with B, where A and B are valid strings, or it can be written as A, where A is a valid string. This is a hard problem to understand. I actually don't understand what we're trying to do. What makes something valid? I just still don't understand. Is it because 1, 2, 1, 2, 1, 1? Okay. Okay. It seems like I have to make a, like, this parenthesis is like a weird one, I guess, right? So like I can probably do like L E E. Oh, we add this to the stack, right? And then we expect to find a closing one. Oh, yep, that's fine. So we can leave that. Then we add this. And we add that, and then we have this, but the expected thing is not the closing. So, yeah. So we can pop that off. Okay, I think that's fine. Well, we have some stack here. For every character in S, if character equals closing, right? Right, so if character in stack or in s, if character equals this, then okay, I will, and stack of this equals I guess does not equal this, I guess. Oh wait, hold on, I can't do that. Right? Because the closing for this is not gonna be right there. Maybe I have a result here, right? And we'll have an actual stack of a stack of parentheses, right? Right. So one is gonna be obviously the strings and the things we can add, and we'll obviously return res this join deres character equals this and stack -1 equals greater, right? If character equals this and stack -1 does not equal that, if stack is this and stack -1 does not equal that, okay, actually this is wrong. So if character equals opening and the stack, okay, yeah, it's fine. Oh, yeah, does not equal a closing, I guess. Because right now, if we just consider only the parentheses, right, we have something like this and an extra one, and we just want to get rid of that, right? And it does not equal that, then how should I write this? Okay, I'm actually so confused. Okay, so if character equals the opening and the stack, right, equals stack of -1, we know that the end of the list is something, then do something else, right? Equals oops, right, if it doesn't equal that, if it does, then res dot append chair and stack append, right? If not, okay, let's say if it doesn't, right? Actually, okay. You know what? Okay, we just skip it. Let's make ourselves look like we skip it. And so the stack of that one doesn't equal that, then we skip it. Otherwise, right, we just skip it. Like, oh, no. Right? if character equals closing, I should do that instead. If the character equals this, right? Then stack bomb 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 bomb. Oh, we don't have it. Okay, if it equals this, and stack of does not equal does not equal this, then we have an issue. We should continue, right? Otherwise, we can res dot append character res dot or res dot append stack dot append character as well. If character equals this, or character equals okay, I'm actually all over the place right now. So if the character equals opening or the character equals this, stack that append I hate using continue. That's why I'm trying to figure out like a better way to write this. Like, okay, res the append char, right? I guess we do an elif. Else res the append char. Oh, okay, hold on. Hold on. I feel like there's a better way to write this. If we find an opening, let me make this a bit more general, right? There could be more cases here, right? So if we find an closing, right? Check if stack and stack of -1 equals this. Then res dot append character stack dot append character, right? Let me right. If there is nothing there, then that's bad. So yeah, that's yeah. So we skip it. If character equals and then we just continue. Or not continue, we'll do a else elif character equals. Do we need to do this case? Okay, res is taking everything. Res is taking everything. Right? I don't know, res is taking what we want it to take, as in like. So we'll take LE. Bro, this isn't that hard actually. I can't think straight. Brain is so messed up. Okay. We iterate through. If character is this and stack is this, then and that, then we're good. Otherwise, we skip that entirely, right? I guess, and yeah, that's the happy case. Else is implied. Otherwise, res dot append. I guess if character equals this, res dot append, or stack dot append, character, res dot append character. Res takes everything, stack doesn't take anything else. How does this look? Wow. That sucks. Oh. A little better. Okay. Let me think this straight. I need to build a stack that takes the parentheses and a stack that takes the string we're kind of building, right? So I want to take, right? Oh, we found a parentheses, add it to the stack. Yep. Also we can add it to Also, we can add it to the thing. Okay, I'm actually making 0 sense right now. I don't know why my brain isn't. This is a simple stack problem. Why can't I think straight? Okay. We add. And then if we've never closed it, then we should probably remove them. Should we do like count how many they are? There's a total of 5. Like these are good because they form a parenthesis. These are good because they form a parentheses. This one doesn't because it doesn't close anything else. So like we do L, so L, E, E. Oh, we're good. Okay, we have this, and then we're finding, and we never Okay, so we keep move. We add in this one. We're assuming that there is a closing somewhere. We can also add this. Okay, actually, I have to do a 2-pass. Let's do this instead. I have another idea. Maybe we can do instead is iterate through the list or the string and check if every single character is like, okay, we count, not necessarily count. Do we want to count, I guess? I'm trying to figure out what we can do here, like we have this here, this here, this here, this here. Like we have to mark the bad ones, and the bad ones are the ones that are, um, the bad ones are the ones that you need to get. My God, I can't think right now. This is so hard. Why am I? This is not even that hard. It's like a really easy problem. It's a stack problems. Like if you can't close it, then you get rid of it. But how do I get rid of it if I have a like? It's just like what am I doing wrong here? Like I was thinking of, okay, you go through the string once, find the index parentheses that are not like like bad, like that are bad. They're bad if they're kind of like paired. So like, okay, go through the string, check, and find parentheses that are bad. Bad meaning there is no opening and closing pair. Okay, so for example, so let's actually figure those out, right? So we'll do this for every character in S. If character, let's do the stack here. All right. If character I need the index, so I'm gonna enumerate. So we'll do I. If character equals. Okay, so if character equals this, then we're good. We'll add that to the stack. Stack dot append. Bad indexes. We'll have a list of those too. Bad indexes we append. Like if lf character equals this, we need to find the latest character opening. So if stack and stack of -1 equals this, then stack.pop, right? Else that is an index to bad indexes dot append I. Okay, that's kind of what I can go for. If stack and stack -1 equals this, then we can pop. Otherwise, we append I. Okay. So now, then we'll do a new. I'm gonna use a list so it's more efficient. We'll do join res, and we'll do For every character I in range of, actually for every in I in bad indexes. Oh, no, no. Oh, no, 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 no. I should have a set here because it's more of a lookup. Add. For every S in, or I guess for every character in S, if, I gotta also do a I enumerate if I is correct. Okay, so if if I in bad index, okay, if it's not in, then res dot append character, then you join everything else. Bro, what? If stack and stack of -1 equals this. Am I not doing this right here? Let me print bad. Nine, 12. Why is there actually? Should only be one actually. Wait, what's going on with the stack actually? Print stack. 3, 5. Oh, whoa, 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 whoa. That's why. Character. Yeah. Better. So we have, yeah, boom. This one's good. But now, why does this one fail? Because, that makes sense. If it equals this, stacked out append. Gotcha. I guess we can say if stack, it should technically, nah, these are like yeah, they have one, but this one is, what am I doing wrong here? Yeah, if I do this, then I gotta get rid of that. Wait, so character is this one. So we is this if stack, else add that, and then here oh, I see. We only remove these two. I want to remove these two as well because they never have an ending. Uh-oh. Because I also want to remove these two. But I do know they're in the stack though, so that's nice. Okay, I'll do this instead. I'm gonna add the index instead. Not in batteries and not in, and I not in stack. How do you join? Join two sets. Python. I think it's like a union, right? Join sets. Union. Is there an easier way? Okay, yeah. Set 1 and 2. Okay. Let's do this. Black listed. It's stack and bad indexes. And bad indexes. So you just check blacklisted, not in blacklisted. Okay, so now it's more of a different logic, right? So let me think about this. So if stack this, then we add that to the thing. elif if character equals this. Actually, I guess so if the character is in the thing, then add it. If the character equals closing, then append stack dot append, or stack is like, I don't know, else stack dot pop. Well, I don't want to pop if it's a character. I just want to. If not stack, bad indexes dot append. Or okay, I just make okay. If character equals this, right? Then if not stack, right? If stack and stack of -1 equals this or this, then stack dot pop. Otherwise, stack or not stack, bad indexes dot add I, right? So let's see this. Oh, you can't do that. Oh, I gotta make this a set, and then boom. What? I just got rid of all the. We so add him. Let me check this. Print. Okay, if character equals. Okay, I guess if character not in. You just skip it too. Don't even consider adding him. Okay, I don't think that makes a difference because my code doesn't really check for that. But I guess I'll skip that. If character is this, then append it to the thing. Oh, okay. No, it's fine. If the stack is something there and the last one. Oh my god. I forgot. It's okay. If stack, then stack dot pop. Otherwise, add that. I forgot that they're numbers, not the characters. Yes. Okay, that makes sense. All right. Thanks for watching. I'll see you guys tomorrow.